Okay, so this video is just how to find the slope when you're given two coordinate points. So we've been able to find the slope from a graph, but now you don't even need a graph. If you're given two coordinate points, you'll be able to find the slope. So remember that slope is rise over run. And so when you rise, that's in the y direction, and when you run, that's in the x direction. So if you have two coordinate points, let's just come up with a couple here. Okay, if I have two coordinate points here, I can call one of them point 1 and one of them point 2. It doesn't matter which way you go. But so I'm going to be looking at the difference between my y values, this 2 and this 6, because they're the y values. That's my rise. It's the difference between the y values. And then I'm going to look at the difference between the x values, the 1 and the 5. So there's a formula for it. So you look at the difference between the y values, and then put it over the difference between the x values. So this formula looks kind of scary, but let me clarify it a little. So go back over to our two example points over here, 1, 2, and 5, 6. I'm going to call 1, 2, point 1. And because a point is x, y, I can call it x1, y1, because it's point 1. So I'm just going to give these x's and y's a number to distinguish which point they go with. And then the second one over here, I'm going to call it x2, y2. So you can flip them if you want to. I'll show you in a little bit how it doesn't matter which one is which one is point 1 and which one's point 2. But so here, let's just go down here. So I've got x1 equals 1. And I've got y1 equals 2 from that coordinate point. And then the second coordinate point, I've got x2 equals 5 and y2 equals 6, just straight from my coordinate point. Okay, so you have all four of those numbers. You can go plug them into the formula for slope. So let me do that down here. So I've got slope. So y2 is 6, y1 is 2, x2 is 5, x1 is 1. Okay, so you just plug in all your numbers and then we'll simplify. So 6 minus 2, just focus on the top. 6 minus 2 is 4. 5 minus 1 on the bottom is 4 also. And then you do want to simplify your fractions. So 4 over 4, that's 1. So my slope here is 1. Okay, so the important part is just identifying y2, y1, x2, and x1, and then plug them all in and simplify. Okay, so let's go on to a few examples. Okay, if I have 2, 1 and 3, 4, let's call this 2, 1 will be point 1. And 3, 4 will be point 2. So I've got x1 is 2, y1 is 1, x2 is 3, and y2 is 4. Just straight from my coordinate points. And then let's remember our formula. I'll write it down again up here. Okay, so then you can go ahead and plug all this stuff in. So I've got the slope. Let's see, y2 is 4, y1 is 1, x2 is 3, and x1 is 2. Okay, so first just plug everything in, and then we'll simplify. So on the top I've got 4 minus 1, that's just 3, and on the bottom I have 3 minus 2, which is just 1. So you can simplify this further if you want to. It's just 3. That's my slope. Okay, let's do another example. Alright, this time I've got a negative in there. So let me write my formula again. Okay, so over in this first coordinate point, we'll make 10, -1 be the first point. So I've got x1 is 10, y1 is -1. In the second point, I've got x2 is 2, and y2 is 5. Okay, and then go ahead and plug that stuff in. So y2 is 5 minus, okay, we got to be careful with our negatives. So minus a -1 because y1 was -1. Then x2 is 2, x1 is 10. Okay, so I've got a lot of negatives going on here, so I got to be careful with that. So when I simplify, 5 minus a -1 really becomes like a +1. Because those negatives cancel each other out. So I really have 5 plus 1 on top, that's 6. Then on the bottom, 2 minus 10, that is a -8. Okay, and then I want to simplify this. Both the numerator and the denominator can be divided by 2. So the numerator will be 3, the denominator will be -4. So my slope is -3/4. Okay, I want to do one more example with lots of negatives here, and then I'll show you that it doesn't matter which point is point 1 and which one is point 2. Okay, so here I've got, oh, let me write my formula. Okay, so x1 is -3. Oh dear. Oh dear. Okay, y1 is -4, x2 is 1, y2 is -2. So plug all this stuff in. y2 is -2. And be careful with your negatives here. It's minus a -4. x2 is 1. And then minus a -3. Okay, so in both of these cases, these minus and negatives, they're going to turn into plus because the negatives cancel. So I really have -2 plus 4, that's 2. And then I have a 1 plus 3, that's 4. And then remember, you need to reduce this. So both the numerator and the denominator are divisible by 2. So this will simplify to 1/2. And it's positive. Alright, so let me do one last example where I switch up the coordinates. We'll just keep it simple. No negatives. Okay, so the first go around, I'm going to call this x1, y1, and this point x2, y2. Don't forget your parentheses. Okay, so when I go plug this in, I will have 4 minus a 1 from y2 minus y1. Then I will have a 3 minus a 0 for x2 minus x1. This simplifies to a 3 on top and a 3 on the bottom. That worked out nice. And then that simplifies to a 1. So my slope is a positive 1 here. Now, suppose I switch these. And let me just erase this. If I make the first point over here x2, y2, And the next one, x1, y1. Let's see what happens. So I'll have a 1 minus a 4 for y2 minus y1. And then I'll have a 0 minus a 3 for x2 minus x1. And if I simplify this, I get a negative 3 on top and a negative 3 on the bottom. So this, I can simplify more. Those negatives cancel each other out. If you divide a negative by a negative, they cancel. So it's really 3 over 3, which looks just like the other one. It's just 1. So if you did switch your coordinates, it's fine. You'll end up with a negative on the top and a negative on the bottom, and they cancel each other out, so it works out to be the exact same.